But then that takes time. Everything takes time. Speaking of time, let's try this. Okay, it might work. Ready?
No, it's not going to work.
Oh, it didn't work. Let's try now. What is this? It's magic. Okay, let's talk about velocity. You guys heard velocity before, yes? Velocity, you'll find, is just like speed. But it has the added value of having a direction. So a lot of times on the news or in shows, they'll get this wrong. Physics is just ordinary stuff, but it's very with a twist, because it's in a lot of sense it takes common sense and then puts it into a different category. Because what you'll find in the common world is that take these terms and then they slightly alter them so that your thinking from a young age isn't quite right. So every time you see a velocity or hear velocity where they use the term velocity, it has to have a direction as well. And so that makes velocity into a vector because it has a quantity with a direction. So velocity has to have a direction. All it is speed in a given direction. Yes? Okay. So, same thing with velocities. You can add them together. So, you get a large velocity this way. If you get a velocity plus this way, then you would get velocity of 0. Or if you added this plus this, then your resultant vector is off like that. Yes? So you always need direction with velocity. And the resultant vector, if it's up and down, you can still get the a squared plus b squared equals c squared, generally. Okay. So you can combine velocities. So let's say we take, let's say Mr. Schuth. And Mr. Schuth decides to go on his rollerblades. Right? Mr. Schuth. Okay. So there's Mr. Schuth, and he's rollerblading, and he's just really fast. So he's rollerblading at 8 meters per second in this direction. Yes? And then all of a sudden, he just spends a lot of time at the airport because he's going on the moving walkway, which is moving at 4 meters per second. That way. Yes? So, you would say relative to the ground, while he's on the moving walkway, how fast is Mr. Schuth traveling? Yes?
12 meters.
12 meters per second. Because you would add that plus that. And what is Mr. Schuth's velocity? Yes?
12 meters per second.
12 meters per second?
That way.
To the right. Exactly. So you'd say 12 meters per second to the right. We could say he happens to be going towards the airport. Or towards the terminal.
So when it's this direction, doesn't it necessarily have to be like north, south, east, or west?
Correct. It often is, but it doesn't have to be. It could be towards the ground. It could be towards the sky. It could be towards Grandma's house.
Okay.
So, you know, like, over the river and through the woods to Grandma's house we go. If you gave it quantity, then it would also be velocity.
Cool.
Because we have the direction. Okay, what if on the other hand, it's not going that way, but it's going this way? 4 meters per second. Then what is Mr. Schuth? I guess we have an eraser here, don't we?
Then you would be moving 4 meters per second right.
Okay, so then we would be 8 going this way plus 4 going this way. So our resultant vector is going to be 4 going this way, right? 4 meters per second. We're okay with that? Yes?
Yes.
All right. So that's okay. Now, what if on the other hand, Mr. Schuth goes to a special place, and it's got a giant moving walkway?
It's like a highway.
Yeah, like a moving highway. Yeah, that's what it is. Moving highway. And it's going at 4 meters per second, right? But Mr. Schuth isn't going with it or against it. Mr. Schuth is going across it. So Mr. Schuth is going 8 meters per second across this moving highway. Oh, God. Now, let's say it takes him, 1 second to get across. Mm-mm-mm.
Oh, really?
Yes?
Oh, really?
So where does Mr. Schuth end up? More.
He would make it across in 1 second, which would mean that it would pull him 4 meters down.
Exactly. So he's going to spend 1 second on here, and since, okay, so we say, okay, distance is what? Let's see, his speed is distance over time. The distance, once again, is speed times time. If our speed is 4 meters per second and our time is 1 second, then second factor out is 4 meters. So we're going to say, whoop, whoop, whoop. We're going to end up right here, 4 meters down. That's where Mr. Schuth is. Right?
Yeah.
Yes? Because what we did is we added this 8 meters per second to this 4 meters per second, and we ended up right there. Right? So, what is Mr. Schuth's velocity? Well, you would say, okay, the c is going to equal a squared plus b squared, square root of that. And so we take the 8 squared plus the 4 squared. And what is his velocity? So 64 plus 16 is 80. What's square root of 80? You want to get a calculator?
I've got one.
It's a little under 9. Barely under 9.
8.944.
8.944
Yes.
meters per second. And that's what we could say it. Toward the hot dog stand. How about that? So, we'd have to have a direction, or we could say southeast or something like that. We could say, okay, that's what that vector equals.
North
Right.
by north.
Let's try another one.
By north.
Ready?
Just for
What if... Oh, here's a tricky one. What if Mr. Schuth
I speak Spanish.
is going canoeing instead in his rollerblades?
Why?
And Mr. Schuth can paddle at 10 meters per second. And he is going to start right here. And he's going to paddle upstream versus the downstream current of 5 meters per second. Right? Now what is Mr. Schuth's relative speed to the ground? Yes?
10 meters per second. No, 5 meters. No, relative.
Relative to the ground right here.
Oh, 5.
It's going to be 5, right? Because it is 5 plus 10. So it's going to be, it's going to equal 5 going this way, right? We're okay with that? What if, on the other hand, Mrs. Schuth,
You're married.
I am married, so she gets in the river here, and she paddles at 5 meters per second, and she's going to go downstream. Now, relative to the ground, how fast is Mrs. Schuth going? Yes?
Mrs. Schuth is going 10.
She's going 10 meters per second down, right? So, this 10 meters per second down, is that a speed or is that a velocity?
Velocity.
It's velocity. This 5 meters per second up,
Velocity.
velocity, right? So, what if Mrs. Schuth and Mr. Schuth are separated by 90 meters? How long will it take for them to meet? Yes?
Whoa.
Right?
Would it be 90 divided by 15?
You'd have to do that, right? Because she's going downstream at 10 meters per second, and I'm going upstream at 5 meters per second. Correct? So together we're getting closer at a total of 15 meters per second.
It would take 6 seconds.
And so the question was, oh golly, here's that formula again, S equals D over T. We're asking about time. So that's what, D over S? Right? So distance is 90 meters, the time, or the speed is 15 meters per second that we're getting closer. So 90 divided by 15 is?
6
6 what?
seconds.
It'll take us 6 seconds to meet. Hopefully it won't fly too hard.
Oh, that'd be
Questions on this stuff? Alright, now the thing that I didn't mention was all that factor label stuff. 52, we're good, okay. So, Factor label. I'm sure you've seen this before. I'm sure you've seen it in a math class. I'm going to assume that you can do it. So let's say that Mr. Shoes so 10 meters per second. I wanted to know what is that in meters per hour. So what you need to realize is that 10 meters per second is 10 meters per second. It really does mean 10 meters over 1 second. And in order to get from one unit to another, you have to multiply by something that will not change the amount of what's there. And so you multiply by a factor of 1. You say, okay, I want to go from hours to seconds. In order to get rid of seconds, what do you have to do? Steele?
Well, you have to put seconds on the top.
You have to put seconds on the top. So that way, it will factor out. Now we're trying to get to hours, right? Yeah?
So
360.
So we're going to hours. Which is bigger, Steele, an hour or a second? An hour. And so you always put a 1 with the bigger amount, the bigger quantity.
360.
And so how many seconds in an hour? 3,600, you say? So there you have it. And just so we are very clear, that equals 10 meters times 3,600 seconds, all over seconds times 1 hour. Right? And so you see that seconds over seconds is 1. So that reduces to just meters per hour, which is what we're looking for, right? And then you multiply it through. What is 10 times 3,600? 36000 meters. I did not lose the unit. And it's all over 1 times 1 hour, which is 1 hour. Now I could put the 1 there, or I could just leave it at hour, right?
You're very fast entrepreneur.
I'm amazing. Amazing. What I'm going down to. Okay? Now let's do another one. What if, on the other hand, I'm up in Canada, eh? Right? So I'm up in Canada, I'm canoeing in Canada, and I'm going 25 kilometers per second. I happen to be in a jet or something, right? And my question was, how many miles per hour is that? Yes? So, I say 25 kilometers per second. What am I going to get rid of first? Seconds. I'll get rid of seconds first. So Steele says to get rid of the seconds, which is the denominator, I have to put it in the numerator, and so I do. And I'm going to go straight to hours because we just figured that out. Hours is the bigger one. All right, we'll fill in the number in a second. Oh, so to speak. How many seconds in an hour? We found there were 3,600. 60 times 60. Now, the next thing is kilometers to miles. I want to get rid of kilometers. So since it's in the numerator, I'm going to put it in the denominator. And I want to go to miles. Well, how many kilometers per mile? Which is bigger, a mile or a kilometer?
Mile.
A mile is bigger. How many kilometers in a mile?
I think there's like
0.6214.
1.61 kilometers per mile. Yes? So then, that's going to equal 25 kilometers times 3,600 seconds times 1 mile. And that's all over seconds times 1 hour times 1.61 kilometers equals, and then you do the math. You notice that kilometers factors out, seconds factor out, you're left with miles per hour, which is exactly what you want.
55900.62112.
So 55
900.
miles per hour. Now, couple conversion I want you to know.
Mr. Shoot, it's 55,900.
There you go.
Oh, right.
Yes, 1 inch equals 2.54 centimeters. That's one you're going to have to know and memorize and love. Okay?
Yeah, here's that all in one sheet. Without even going to the back. Oh, I'm going to